Let's start with type 1 questions. I have to prove that for all n greater than equals to 1, prove that 1 square plus 2 square plus 3 square plus 4 square up to n square is equals to n into n plus 1 into 2n plus 1 by 6. Alright. And one thing I just would like to make you clear. Now the statement is given for n greater than equals to 1. N greater than equals to 1. And when we were doing the steps of principle of mathematical induction, we said the statement P1 is true. But if some statement is given which starts from here, that n is greater than equals to 4. So my first step will not be P1 is true. Then it will be P4. It depends upon the what statement is given to you and what condition is given along with it. Is it clear? If some statement is given, it is true for n, we prove that it is true for n greater than equals to 4. So my first step will be P4 is true. P4 is true. Is it clear? This you have to keep in your mind very clearly. This is just the first property. It depends upon what is given to me in the question. Alright? Fine. Now what I'll do, let Pn be the given statement. Alright? So I name it as Pn. Fine. Now, step 1. Let n is equals to 1. I have to prove that the statement is true for n is equals to 1. So what I'll do? My left hand side. So I need to find out P1. What is P1? 1 square. That is 1. Clear? Let's check right hand side. What is right hand side? Now I'll put n is equals to 1 here. 1 plus 1, 2 plus 1 by 6. That is 2 into 3 by 6. That is 6 by 6. That's 1. So left hand side is equals to right hand side. It means P1 is true. P1 is true. Is it clear? P1 is true. So my first step is to take n is equals to 1. I need to put n is equals to 1. And for that I need to prove that the result is true for n is equals to 1. Now the step 2. What is step 2? Let us assume that result is true for n is equals to k. So this I am taking the result is true for n is equals to k. Is it clear? That means pk is true. That I am considering, I am assuming that pk is true. What will be pk? 1 square, 2 square, 3 square, 4 square up to k square. In place of n, I am going to substitute k because I don't need p and I need now pk. So wherever n is there, I am going to put k. So this statement I am taking as true. Fine, this statement is true. Now step 3. What will be step 3? Step 3, let us prove the result true for n is equals to k plus 1. Now if I take n is equals to k plus 1, I have to prove the result true for it. I have to prove that pk plus 1 is true whenever we take pk is true. Is it clear? So let's find out first of all pk plus 1. Let's see proof क्या करना है. I need to prove. Now in place of n, what do I need? I need k plus 1. Clear? So, in place of n, wherever n is there, change into k plus 1. N will become k plus 1. If I put n is equals to k plus 1 here, if I put n is equals to k plus 1 here, what it will become? In place of n, k plus 1, 1 already है वहाँ पर, so it will become k plus 2. Clear? अब इसको check करते हैं. n की जगह पर I need to put k plus 1. Always keep a bracket, children. Students ने commit a mistake. n की जगह सिर्फ k plus 1 लिख दिया. They forget about that 2 बाहर लिखा हुआ है. 2 है, पहले वो multiply होगा, then it is going to be added. That we need to keep in mind. तो ये क्या बन जाएगा? It will become 2k plus 3. समझ आया? So this will become 2k plus 3 by 6. This is what I have to prove. I have to prove, girls. Clear? This is what I have to prove, students. Now, prove means I have to prove this left hand side is equals to right hand side. I have to prove left hand side is equals to right hand side. So what I'm going to do, I'll take left hand side. Take left hand side. What is left hand side? And I need to prove it equals to right hand side. Alright. Can we write the second last term? Last is k plus 1 whole square. तो इससे पिछली वाली क्या होगी? अगर ये टर्म है k plus 1, the previous would be k. ऐसे ही आ रहा है. ये 3 है, this is 2, this is 1, यहाँ था 4. So अगर this is k plus 1, so previous term is going to be k. Clear? Square तो है सबके साथ, square will remain there. Now because this result we have taken as true, so I will be finding the value. अब इसका value put करेंगे यहाँ से here. Always keep in mind, whenever you write the previous term of this will be always the last term of it. Because यहाँ k था, हमने उससे k plus 1 ही तो लिखा है, उससे next term में तो लिखिए. So my previous term will always the last term of the previous step. Alright. Now from here, I'll put the value from 1 square to k square here. What is that? That is k plus 1, 2k plus 1 by 6 plus k plus 1 whole square. Alright? Clear everyone? Now I need to simplify. Now we need to simplify. For simplification, always keep in mind, don't start directly taking LCM. If something is coming common, you should take common first of all. K plus 1 is in both the terms, let's take it common. Inside I have k, 2k plus 1 by 6. Now I'll take LCM. Multiply. It is 2k square plus 7k plus 6 by 6. We'll make the factors. You all know the factorization, the middle term splitting, that you can easily make the factors of it. And the factors of it is going to be we have already split the middle term. Now, if I just take common, the grown-up children, you know how to take common all this. So it's become k plus 2 and the next factor is 2k plus 3 by 6. What is it? This is my right hand side. That's what I wanted. That's my right hand side. Is this clear? Alright. So what does it indicate? Now what have we proven? That P1 is true, PK plus 1 is true whenever PK is true. So these were the conditions of our mathematical mathematical induction, the principle which we have done. Therefore, by PMI, the principle of mathematical induction, we can write this principle of mathematical induction as PMI. You don't have to write every time the bigger one. PMI, the result, the statement is true for n greater than equals to 1, that is for natural numbers. Alright children, so what are the 3 steps which we have followed? First of all, I will prove the statement for true for n is equals to 1. Again, it depends upon the question. If it is given n greater than equals to 4, you have to prove it for 4 first of all. So n equals to 1. Then I'll assume the result is true for n is equals to k. Then I will prove that the result is true for n is equals to k plus 1. If these two things are proven, then we say by PMI the result is true for every natural number. The next example children, alright, the type 1 only we are going to continue right now. So what is my first step? By now you might have remembered this. Let Pn, I give it a name as Pn 1 upon 1 upon 1 into 2, 1 upon 2 into 3, 1 upon 3 into 4, up to 1 upon n into n plus 1. I have to prove this equals to n upon n plus 1 for all n greater than equals to 1. For all n greater than equals to 1. Alright. So let's start. You know what is step 1? Let n is equals to 1. Let's prove the result true for n is equals to 1. So what's my left hand side? P1. What is P1? The first. This is P1. So that is 1 by 2. Let's pick up right hand side. What is right hand side? N upon n plus 1. In place of n, I am going to put 1. 1 into 1 plus 1 upon 1 plus 1 will be 1 by 2. So therefore, left hand side is equals to right hand side. It means the statement is true for n is equals to 1 or P1 is true. P1 is true. Now the next step. You remember it now. What do we do in the second step? Second step, we assume that the result is true for n is equals to k. We assume that, let us suppose that result is true for n is equals to k. That means this pk is true. Pk is true. That means the pk is true. Let's find out pk. That means what do I need to do? I need to replace n by k. That's it. It's very simple. I have to replace n by k. And I need to prove it. This is fine. This is my assumption. The second step, we assume that the result is true for n is equals to k. Now what do we do? Now the step 3, let us prove the result for n is equals to k plus 1. That I have to prove. That means this pk plus 1 I have to prove. What will be it be? 1 upon 1 into 2, 1 upon 2 into 3, so on up to 1 upon k into k plus 1. Now what am I writing? I am writing pk plus 1. So what shall I do? I should change this n into k plus 1. So what it will become? This will become k plus 1, and this will become, in place of n I am putting k plus 1 plus 1, it will become k plus 2. Because you have to be careful while solving it, and then right hand side in place of n k plus 1, and it will become k plus 2. Alright. Now what do we do? What is the next step? We will pick up left hand side. What is my left hand side? I have to prove it equals to right hand side. I have to prove it equals to right hand side. What is the step? What did I tell you in the previous example? We have to write the second last term. Second last term. If it is k plus 1, the previous term to it would be k. If it is k plus 2, the previous term to it will be k plus 1. And I told you one more thing. The previous term, the second last term is always the last term of the previous step. Okay? pk ka last term is always this one. Now what do? We put the values. We always have to put the values. From the second step, I have to put the value, that is up to here. The value is k upon k plus 1, and this I have. Solve it. I can take 1 upon k plus 1 common. What is left inside? K plus 1 upon k plus 2. Clear? Take LCM. It will become k square plus 2k plus 1 upon k plus 2. What it is? K square plus 2k plus 1. This is a square plus 2ab plus b square. That's the formula of a plus b whole square. That's the formula of k plus 1 whole square. Clear? K plus 1 cancel. K plus 1 and k plus 1 cancel. What are we left with? K plus 1 upon k plus 2. Now, that means what I have got? I got it as k plus 1 upon k plus 2. What is it? What is it? That's my right hand side. What I have to prove. Is it clear? Which is equals to right hand side. So what results we have got? What results we have got? P1 is true. This is first thing which we have got. Second, pk plus 1 is true whenever pk is true. Therefore, by PMI, Pn is true for all natural numbers greater than or equals to 1. Very easy, children. 3 fixed steps. I'll prove the result for n is equals to 1. I'll assume the result for n is equals to k. I'll prove the result for n is equals to k plus 1. If all these 3 steps are done, then we say by PMI the result is true for all n natural numbers.